What if the most dangerous thing in a galaxy is no longer trapped at its center? A supermassive black hole is supposed to be the anchor, the fixed weight at the heart of a galaxy. But astronomers have found cases suggesting one of these monsters may be displaced, shoved away from the center that should hold it. And if that is true, this is not just a weird cosmic footnote. It means galaxy collisions may leave behind roaming gravitational predators capable of tearing through gas, disrupting star formation, and rewriting how galaxies recover after impact. The mystery starts with a basic assumption. When galaxies merge, their central black holes should sink toward the new center, like lead balls settling in deep water. That is the standard picture. It is elegant, it is comforting. And I think that comfort is exactly why this story matters. We like to imagine the most violent forces in the universe still obeying a kind of cosmic order. But some observations hint at the opposite. A black hole can be kicked hard. The mechanism is almost absurd. Two supermassive black holes spiral together after their galaxies merge. They radiate energy as gravitational waves. If that radiation is emitted unevenly in different directions, the final merged black hole gets a recoil kick, like a cannon firing in space with no one holding it down. In extreme simulations, that kick can reach thousands of kilometers per second. Research by Manuela Campanelli and colleagues in 2007 showed recoil velocities up to about 4,000 kilometers per second are possible in the most favorable spin configurations. That is fast enough to eject a black hole from some galaxies entirely. Let that sink in. The object that was supposed to define the center can become the thing that escapes it. So how do you catch something like that? Not by seeing the black hole directly. You infer it from the damage, from the light around it, from the place where the center should be and isn't. Astronomers look for several clues. An active black hole may drag along a tight cocoon of gas and stars, while the broader galaxy stays behind. Emission lines in the spectrum can appear offset in speed. The bright nucleus can appear physically displaced from the galaxy's stellar center. Sometimes there may even be a disturbed trail, a kind of luminous wake through interstellar gas. None of these clues alone is enough. Together, they start to look like a crime scene. And that detective work has become much sharper in recent years. In 2024, a team using the Hubble Space Telescope and Chandra X-ray Observatory reported evidence for a wandering or displaced supermassive black hole in a galaxy around 800 million light-years away, with the active source appearing offset from the center by roughly 3,000 light-years. The object drew attention precisely because it looked wrong in a very specific way. Not random, not messy. Wrong. Like a lock whose key has been forced out. And this is where the story becomes existential. Because a central black hole, strange as it sounds, is part of a galaxy's balance. It can regulate gas through jets and radiation. It can help shape when stars form and when they stop. Move that engine off-center, and now the feedback hits different neighborhoods, different clouds, different futures. A wandering black hole is not just lost. It is carrying influence into places that were never built to absorb it. Personally, that idea is hard to shake. We usually talk about galaxies as if collisions are destructive and then stabilizing, like a storm that eventually settles. But if the central engine itself can be knocked loose, the storm may keep moving inside the wreckage for millions of years. Can you imagine an entire galaxy trying to rebuild while its heaviest object is drifting through it like a hidden wrecking ball? There is already good reason to think black hole mergers happen often across cosmic time. In 2016, LIGO directly detected gravitational waves from merging stellar mass black holes, proving the recoil mechanism is real in principle for black hole collisions, even if those were much smaller objects. At the galaxy scale, simulations have long suggested merged supermassive black holes should also recoil when spins and masses line up the wrong way. The unanswered question was whether nature actually lets us catch one in the act.
So let me ask you this. If you were an astronomer and saw a galaxy with its brightest black hole apparently off-center, would you bet on a recoil kick or a hidden second galaxy core we haven't resolved yet? Put your vote in the comments. Kicked or misidentified? Because there is a serious alternative explanation. Maybe the black hole was never kicked at all. Maybe we are seeing the leftover core of a smaller galaxy that has not fully merged yet. Maybe dust is fooling us? Maybe the apparent center is the wrong center. This is where good science gets uncomfortable. Astronomers don't just hunt anomalies. They try to kill them first. That matters here because a true recoil event would be extraordinary. It would mean gravitational waves did more than ripple space-time. They changed the architecture of a galaxy. And there's a detail many people miss. The black hole may not leave empty-handed. Models suggest it can carry a bound cluster of stars and part of its accretion structure with it. A moving nucleus. A stolen heart. Which means the real threat is not a naked black hole wandering in darkness. It is a compact, active system plowing through gas, heating what it touches, and starving some regions while compressing others. That is how one displaced monster could rewrite survival after a merger. Not by swallowing the whole galaxy, by changing where the galaxy is allowed to grow. And this connects to one of the biggest questions in galaxy evolution. Why do some merger remnants become quiet, red, and nearly sterile, while others reignite with fresh star formation? We usually blame gas supply, mass, environment, timing. Fair enough. But what if in some cases, the answer is simpler and stranger? The thermostat moved. But wait, there is a more unsettling possibility nobody outside astronomy talks about enough. A displaced supermassive black hole may not just be evidence of a past collision. It may be evidence that the merger never truly finished. If the black hole is still wandering, and the galaxy's deepest gravitational hierarchy is still rearranging itself, the visible shape may look settled, while the invisible core is still in crisis. That flips the whole story. We may be labeling some galaxies as survivors when they are actually still internally unstable. In 2023 and 2024, improved multi-wavelength follow-up became crucial for this reason. Optical data can show displacement. X-rays can reveal active feeding. Radio observations can test whether jets line up with the supposed nucleus. The James Webb Space Telescope is also beginning to sharpen how we inspect disturbed galactic cores through dust. The timing matters now because we finally have the resolution, wavelength coverage, and simulation power to separate a true wandering black hole from a messy merger remnant. And in my view, that is the deeper payoff. This is not only a story about one bizarre object. It is a stress test for a comforting assumption in astronomy that the center always reasserts itself. Sometimes it does. Sometimes, after a collision, the center gets punched in the mouth and keeps moving. There is something almost human in that. We imagine the core of a system as the safest place, the organizing truth, the thing that stays put while chaos happens around it. Then, the universe reminds us that even the anchor can be thrown loose. What does a galaxy become when its heart is no longer at home? If future observations confirm more of these objects, galaxy evolution models will have to account for off-center feedback in a much more serious way.
Rates of star formation, gas heating, nuclear activity, even estimates of how often black holes fully merge could shift. A single confirmed wanderer will not overturn all cosmology, but it could force a rewrite of one crucial chapter: what survival actually means after galaxies collide. If that idea hits you as hard as it hit me, that a galaxy can survive the crash but lose control of its own center, leave a like, because the final piece makes this even darker. The darkest part is this: we notice these objects only when they are active, bright, feeding, noisy. A quiet, wandering supermassive black hole would be far harder to catch. So the few candidates we have might be the visible tip of a much larger hidden population. How many displaced monsters are out there right now, moving through the ruins of ancient mergers with almost no light to betray them? That question does not just enlarge the mystery, it changes the odds. A galaxy collision is not always a clean story of destruction and rebirth. Sometimes, it may leave behind a fugitive engine, still armed, still influential, and no longer where physics once told us it belonged. And if the most anchored object in a galaxy can become a wanderer, then maybe cosmic order is less like architecture and more like aftermath. Confessionally, that is what stays with me. Not the scale, not even the violence. It is the image of a center that failed to remain the center. In a universe this old, maybe survival is not about staying intact. Maybe it is about what keeps functioning after the heart has been displaced. If cosmic mysteries like this fascinate you, the moments when the universe breaks its own patterns, subscribe and join this channel. Because out there, the strangest discoveries are often the ones that begin with something being found exactly where it should not be.